Thanks, I'm doing the most. It's okay. Okay, wait. That's what you so
You should have taken my grades.
They would have changed it in Alex. Did everybody else already
It
finish it?
changed it.
If it's past the due date, like if you did your knowledge check before Sunday,
Yeah.
it could change the stuff that was due on Sunday. But once Sunday is over, like this past Sunday, if you do your knowledge check after that, it will change it on Alex, but it will not change it in the class.
So on the 100%, I think after I took my knowledge check, we got 100. Do I have to go back and read the courses again?
No, I think what'll happen is
I just don't.
Alex will automatically give you what you need to do.
Because it lets me go back to all the modules and read. It's like module 4. I did it and then I finished it and then I did my knowledge check. But then after I did my knowledge check, it went down and it's making me redo the stuff I already did.
It is gonna make you redo the stuff you missed, but it should do it through the catch-up module. There's a catch-up module on there and just do that.
One, catch up.
Catch-up
At the
module
end
one.
of the class.
So whatever you missed on there, it will have you do it on that.
So if you missed the one with the knowledge check, like, is it gonna make you redo that before you could get to like module 6?
That's anything that would bear, like if there's something that it feels you don't need for anything else in this course, it'll let you keep putting it on. But say it was making a percent and then you're doing something that uses percents, it's gonna make sure you understand the percents before it lets you go on to it.
Cause I didn't do the knowledge check yet. But I was gonna do it like today, and then I was gonna see if I was gonna be able to do module 6. and stuff.
Well, you do need to do the catch-up module. So if you do the knowledge check and do really well on it, you won't have very many problems on the catch-up module. If you do really bad, then you're gonna have a lot of problems, which is good practice, I guess, for the exam. Yeah, that's why I didn't know if I want to take that off or leave it. I had taken it off, but then I figured, let's see what it does. Because the catch-up module, I don't think I can take that off. I think it's part of the.
I think the teacher before me doesn't like you. They got it up.
At least they raised the board. Sometimes they don't raise the board. Okay. So we will see how this knowledge check and catch-up module goes. If we don't like it, well, I don't know if I can take the catch-up module out, but I know I can take the knowledge check.
Wait, so we're not supposed to do the knowledge check?
You need to do the knowledge check, and we're gonna see what happens. Because if we don't do the knowledge check and you have to do the catch-up module, you're gonna have every single section to do. The knowledge check knocks out stuff from that. So we'll see. But we're gonna worry about our exam first. I made more practice problems. On stuff I thought we needed to look at again, just to make sure. So last class we did, thanks, Julie. We spent 2 hours reviewing. So if you weren't here, definitely get someone's notes. Because the video crashed, I don't know. But anyways, the problems are also on Blackboard that we went over. tomorrow. That's what I was gonna say. Try and do, or at least look over the take-home portion of the exam. That way then you can check with your neighbors and see how your answers match, and if something doesn't match, figure out what's wrong. Or if there's something you have a question on, you can ask me and I can help you. And that's what we'll do tomorrow. I'll take any questions on the in-class part first, but that's what we'll do. Okay. An employee at Candles is finding everyone's favorite flavor of ice cream. She asked the first 50 people that come in, which is their favorite ice cream. What type of sample is this? Random, systematic, stratified, cluster, or convenience? Anyone?
We'll make it calculated.
Convenience? Because she's just sitting there as they come up. What's your favorite ice cream? So convenience is because it's convenient. You're at work, you take the first 50 people and ask them their favorite ice cream. How could we make that a random sample? Think about what random means.
Ask what people throughout the day. Just
In any order, just like. Ask it, as long as you have to be careful not to make it systematic. But that's one way to ask, or you could, I guess it'd be hard to put everyone's favorite in the thing and pull out 50 of them. But random means it's not in any order. Everyone is equally likely. Maybe when they come up, you toss a coin. If it's heads, you pick them. If it's tails, you don't. Then it's random because you're not choosing which one the coin is. But you want to make it somehow so that it's random. Kind of hard when you're just saying, well, I'll take this person, then I'm going to wait a few and take the next one, then I'll do the next one. But if you make it a little more random by tossing a coin, that would work too. But I would accept the other answer. How would we make it systematic?
if we did like every fourth person.
So systematic means you're picking every so many of them. Every fourth person, every fifth person, every 10th person. And you have a system to it. Any questions on that? So the thing with convenience is random sample that we're talking about, it's also convenient because you're just sitting there. So some of these can interchange. But random and systematic, completely different, and make sure you know which is which. Any questions on it? What is the variable? Flavor of ice cream. Is that qualitative or quantitative? Why?
Because it's not a number.
It's not a number. So the variable is favorite flavor of ice cream, and that would be qualitative because it's not numeric. Any questions? What's the sample?
People at the ice cream shop. No, the shop, no people that.
The 50 people. So the ones, well, not the, yeah, I guess it'd be the 50 people. That sample would be what you're getting it from. So it's the 50 people who you ask their favorite ice cream. So the sample is only the group that got you the data. And in this case, it's 50 people. What's the population? Everyone who goes to Handel's Ice Cream. I think, did I make it Boardman? I was going to. Looks like I did. So it would be everyone who goes to Angel's Ice Cream. Oh, I knew it for Boardman somewhere. Any questions on the sample and the population? Okay, so I did have this Boardman in here. You could say that the population was everyone who buys ice cream from that shop or any of the handles. It's a, any of them would work. Some would be biased because it's only at one handle. The population goes on to a larger group. She found that from the sample of customers at the Boardman location, pistachio is their favorite ice cream, which is probably not, but it's my favorite. Why is this a descriptive statement? So she found that from the sample of customers at the Boardman location, pistachio is their favorite ice cream. Why is it descriptive? What's descriptive statement? And so from the sample, so she's just talking about what she found from the sample. And that makes it descriptive. How could we make it an inferential statement? I couldn't hear you. Yes, make up the whole population. So people at hand, customers that go to Handel's Ice Cream prefer pistachio. Something that uses the population. So descriptive uses your sample. And inferential uses your population. Think of descriptive, it describes what you found. It just stays in that group. Inferential, you infer it onto the population. Any questions on that? Was this an observational or experimental study? Yeah, she just observed what the favorite ice cream was. It wasn't like she was saying, oh, the special today is this and it's so good, and then trying to get people to go another way and see if they would. You need to be testing something to make it experimental. If you're just finding measurements, that is just an observation. And in this case, we were finding favorite ice cream. Any questions on the difference between observational and experimental? If she was interested in all Handel's locations, should she use a cluster or stratified? Which one? It might be right. Depending on how you want to do it, you probably could use either one.
As if she was still doing the 50 people.
So both of them break things into groups. All locations. So if we thought about each Handel's location. What does a cluster do?
Takes whole groups.
Yeah, that takes, I'm double check. No, yeah. I wanted to make sure because sometimes I flip them around. The cluster is going to take whole groups. So if this is each individual store and I take 3 stores, am I going to get a good sampling of each of the stores? No. So for this type of situation, this is not necessarily a good idea because then we're leaving stores out. Where stratified takes so many from each group. So maybe we take 10 from each group. Then I'm getting a sampling of all of the stores. So in this case, this would be a better idea because you're taking some from every store. This one's leaving stores out, so it's not as good of a sample. It's kind of biased. So there'll definitely be a question on there where you have to choose which one you prefer and explain it. And you know, if you pick the other one, as long as you explain it good. So the biggest thing is making sure you understand the difference. A cluster makes the groups, but it takes whole groups. If I took 10 calculus classes and then I took everyone from 5 of those classes, that's not bad because it's all calc classes. So then you're just picking 5 of them. A cluster would work. But if we were talking about freshman, sophomore, junior, senior, and I only pick 2 of the groups, all the freshmen and all the seniors, you're not hearing anything from the sophomores and the juniors. So a cluster wouldn't be good in that case. You'd rather take some from each grade level. Any questions on that? You can tell I'm hungry for ice cream. Okay. Any questions on the last problem? The average turtle swims at 11 miles per hour. And a standard deviation of 1.5. Draw the normal curve, including the points under the curve, or the percentages under the curve. You need to memorize those percents. They're always the same. Should add up to 100, 50 on both sides. Middle is 68%, 34 and 34. And 13.5, 2.35, and 0.1. And these are percents. Going the other way, same thing. So as long as you remember the 4 numbers, and they add up to 50. 50 on one side, 50 on the other. Any questions on that part? Percents will be the same no matter what. In the middle is your mean. And then think of it as a number line and you count by your standard deviation. In this case, it's 1.5. So 11 plus 1.5, 12.5, 14, 15.5. Any questions on the values? Is that what you got? This is important because we're going to use it a lot in other chapters. I think it's 2 points for the percents, 2 points for this row, and then the questions that follow. What percent of turtles swim at most 9.5? Go ahead and answer the questions. Memorize the formula for the z-score. It's your x value minus the mean divided by your standard deviation. Oh, I didn't realize I picked one that was right on the line. At most 9.5. What percent of turtles swim at most 9.5 miles per hour? 16%. 15, 16. Most 9.5 at most means up to, so it would be these. We would add up these. So at most 9.5 means up to, but not including. I always think of money when I'm talking about, if I have at most $9.5, I don't have more than that. And then just add the percent. The z-score, you said 8. Get a -2. So what does that z-score mean? You don't need the negative though, because you're saying below. So the negative means below. You are, or this turtle is 2 standard deviations below the average. He swims 2 standard deviations below the mean. So he's slow. A -2, negative means below. If it were positive, it would be above. Any questions on that? How about an inferential statement? Now, the way we're given this, we don't really know how much was in the sample. So to give a descriptive, you really couldn't do that because we don't know what the sample was from. But we can give an inferential statement. And since I didn't specify in this one, you could have used a lot of different things. The average turtle swims 11 miles per hour. If I told you to make an inferential statement using the 14 miles per hour, then you could say on average, I add these two up, I get 2.5. On average, 2.5% of turtles swim faster than 14 miles per hour. So that would be one thing. On average, 2.5, if I add these two, 2.5% of turtles swim more than 14 miles per hour. If I use the two middle here, 68, because if you add these, 68% of turtles swim between 9.5 and 12.5 miles per hour. So you want to use the percent and you want to use your values and give an inferential statement. I think I actually put either a value or a percentile. So write that down. An inferential statement using the 84th percentile. Well, yeah. I mean, or just think of it in your head, what you would say. So the 84th percentile is what value? If we add these percents, we know to here is 50. Adding 34, you get the 84. So it's 12.5. So 12.5 is the 84th percentile. %84 of turtles swim less than 12.5 miles per hour. Because remember, the percentile tells you the percent below. So when you're making an inferential statement, 84% of turtles swim to 12.5, less than 12.5 miles per hour. Or you could have used above. %16 of turtles swim faster than 12.5 miles per hour. Because remember, your percentile tells you what percent is below. You subtract it from 100, you get the percent that is above. But either one would be fine. It definitely makes sure that you understand what this chart is telling you. Any questions on it? Oh, there's only 8 questions on, I took the one question out because it was on both. I was moving stuff around and left it on. So there's only 8 questions. The tennis team is filling baskets for a fundraiser. You keep track of the number of baskets each person fills and the time they take to fill them. Go ahead and answer the question. What's the variables? Number of baskets and the time you're filling. Are they qualitative, quantitative, one of each? They're both a number, so they're both quantitative. Because the number of baskets you fill is a number and time is a number, so they are both quantitative. Discrete or continuous? Let's go with the number of baskets. The number of baskets, is that discrete or continuous?
Discrete.
It's discrete, why? You're not gonna have part of a basket. Which means the time is probably continuous. Well, I guess it could be discrete also, because they were both born. Why is time continuous?
Decimal.
It can be a decimal, it can be a fraction. You could work a half an hour. This person worked 1.4 hours. So because you can have those fractions and decimals in time, it's continuous. What's the boundary for 1.4? Go one decimal further. Oops, not one further. That would be if you put the 5 in. If you're gonna divide by 2, you use this decimal position, the 10th. Or go one decimal further and add and subtract a 5 in that position. So whatever position this is, divide it by 2, and then add and subtract this. 1.4 minus 0.05 gives us this. 1.4 plus 0.05 gives us this.
Can't we just move over the decimal? And we have to actually divide it?
No, if you can go right to this, it's fine.
So I just add 0 with.
Go one more place. Yep. You can go, this is the 10th, so you use the 5 one more place in the 100th.
Yeah.
If we had 1.26. This is 2 decimal places, so we would add and subtract. Go 1 decimal place further. Any questions on boundaries? Most things we use them for is the frequency table or histogram. Any questions on that one? Okay, read what I wrote first. There was a survey on the internet and 400 Americans responded to it. It asked, what is your usual mode of transportation to work or school? The findings are in the graph below. Go ahead and write your answers or think about what they would be. it's. What type of graph is it? Pie chart, pie graph. What's the sample? The 400 Americans that responded. What's the population? Country, all Americans. That could be too, yep. Because that's true, since this was on the internet. If you're talking about all Americans, it's biased because there's those who that are not on the internet. Which is fine though. I would take either answer. State a descriptive statement. Of the 400 Americans that responded, 40% drive a car to work or school. So descriptive, you only tell me what came from the sample. Where inferential, the whole population. Of all Americans who use the internet, if that's what your population was, 40% of them drive a car to work or school. 10% of them take a train to work. But you want to use the whole population, whatever you chose your population as. That's what you use in your inference. All Americans who use the internet, 10% of them take a train. So any of these percents, but on your whole population, you're implying it on everybody. What's the variable? Transportation. Which means it's qualitative or quantitative? Qualitative, because it's not a number. The answers they're giving are car, bus, bike. How many people in the sample usually ride a bike to work or school? We don't want the percent, we want the number of people. And that's why I put this one in here, because I couldn't remember if we did that or not. But when you want the number of people, this sample had 400. What percent of those 400 rode the bike? 30%. So we want 30% of the 400. $12, $120. Yeah. So 120 people from the sample ride a bike to work or school. What's the mode? Car, yes. So mode doesn't have to be a number. Mode is whatever there was the most of, and the most was the 40%, so it's the car. Any questions on that? There's one other thing, and I didn't put it in here. May ones. Find that. It's a cherry tree. It's the one we used before. There we go. How many cherry trees are 90 feet tall from the sample? 2? None. So remember your sample, 60 goes into this one, but 65 is not in this one, it's here. So it's up to, but not including 65 in this bar. This bar is from 70 up to, but not including 75. So this one's 85 up to, but not including 90. If there was any that were 90, we'd have another bar. So there would be none. I didn't think we mentioned that last class, but I wanted to make sure because it's on the test. So remember your bar, it goes up to, but not including this endpoint. So if you're making a histogram, the right endpoint goes into the next bar. Any questions? Any? On anything? Everyone understands all the definitions, all the. Okay, so for tomorrow, I would. Look over the problems that we did yesterday and today. And I fixed this, it should open now, the review. I would look over this review and make sure you understand anything. If there's anything you have a question on, let me know. I did not put Chevy-Chef's theorem on it, so you don't have to worry about that part, but the empirical rule, that's the normal clip that we did in theory. That's your normal clip. So look over everything, see where you have questions, and after that, we will work on the portion. Make sure to mark the attendance sheet if you have there.